Let's move on. As I said about marinating yourself in indices, more practices are needed. Let's look at simple worked examples and we move on to more challenged ones. If I said 4 to the power of A is 4, well, I'd like to tell you that this is called an equation, a simple equation, and we need to solve. In an equation, we solve. In an expression, we simplify it. The earlier examples you would have seen in the modules on indices were simplifying, but now we're going to progress into solving. Let's find out. 4 to the power of A is 4. And what is the number in front? 1. So that's 4 and 4. So A, you are 1, right? So A is 1. Great. What happened if I said 4 to the power of 2A, you're 4. And what if I don't write any power? There is a ghost power. And that ghostly power, that invisible power that you can't see, is none other than 1 hanging up there. Not -1, not 0. It's not 0, it's 1. So 4 to the power of 2A equal to 4 to the power of 1 tells us that 2A is 1 because they are both 4 and 4. So hence 2A is 1, and that means that your A is equal to 1 over 2. Got it? That's your answer. This is your answer. Just look at the next sum. 2 to the power of A is 4. What is 4? Is 4 related to 2? Very easy, right? 2 squared. So 2 to the power of A is 2 squared. Alright? And so 2 to the power of A is 2 squared. And they're both 2 and 2. So what is A going to be? A is 2. Wonderful. But what did I say if I said 2 to the power of A is 16? Does that make it difficult? No, because you know 16 is 2 to the power of 4. So 2 to the power of A is 16, and 16 is 2 to the power of 4. And you've got it. The solution for A is 4. Yeah. Do not get frightened when the sums gets a little bit more challenging. You just have to recall indices. The laws of indices will be there to guide you through. Let's look at more examples. If I say 2 to the power of 3A minus 1 is equal to 16. Does that make it more difficult? No. Why? Because you know that 16 is 2 to the power of 4. And that's 3A minus 1. Look at that again. Look at it harder. Yes, you see that 3A minus 1 is 4 because they're both 2's. So the powers must be equal. Otherwise, you cannot equate them. So therefore, your 3A minus 1 is 4. And so what is A going to be? When you bring your minus 1 over, you get 3A is equal to 5. And hence, your A will be 5 over 3. Isn't maths getting to be a little bit easier? Let me repeat. 3A minus 1 is 4. Bring your minus 1 over, you get a 5. 3A is 5. So A will be 5 over 3. Let's look at this. Now we're going to 16. It's the reverse. The number is getting big. But you know that 16 is related to 2. We spoke about cousin numbers, didn't we? 16 is 2 to the power of 4. Yes. So if you get 2 to the power of 4, let me change the color of the chalk. 2 to the power of 4 and you've got an x there. 16 is 2 to the power of 4. X is 2. And remember, what's the number in front? 1. Power, power. You multiply the power up. 2 to the power of 4x is 2 to the power of 1. And what does that tell you? This is 2 and 2. Hence, the powers must be equal. Otherwise, they cannot be equal. Alright, so 4x must be equal to 1. And that means that your x is none other than 1/4. Got it? Great. Look at 16. Remember I told this word, prime factorization. Break down your 16. 16 and 128 are related. Know your tables. 16 is 2 to the power of 4. Yes, and you've got x outside. What is 128? Is that number familiar with you? 2, 4, 8, 16, 32, 64, and 128 is 2 to the power of 7. So 128 is 2 to the power of 7. Power, power. We multiply them up. 4x is 2 to the power of 7. You can see that the powers are equal because they're both 2. So you can say that 4x is equal to 7 and x is 7 over 4. You can express it as a mixed number, 1 3/4. Repeat again. Look at the number, analyze it, think through. Hey, they are as 16s. Something is connecting them. What is it? 16 is 2 to the power of 4. Yes, and outside the power is x. 128 is 2 to the power of 7. Find the link, and once you've got it, the solution becomes a lot more easier. You've got a 4x, and here's a 7. These two powers become equal, and hence we solve for x. Got it? Shall we move on? Let's look at this. Breathe in, breathe out. Do not panic. In maths, you got to remain cool as a cucumber. Let the laws of indices guide you through in solving this sum. Look at 9, look at 3, look at 3 again. They all have a common relative. That common relative, the number is 3. You can break this 9 to 3 to the power of 2. And then you've got an x plus 1 there. And here you've got times 3x minus 3. And you have 3 to the power of 4. Remember the law, am times n, the power law. You can apply it. Every number here multiply by 2. What do you get? You get 3 to the power of 2x plus 2. Yes. And here times 3 to the power of 3x minus 3 equals to 3 to the power of 4. When you multiply, remember your laws of indices, am times an. They are common term. You just add up the powers. When you add them up, you get 2x plus 2 plus 3x minus 3. You add them up, you get a 5x. 2 minus 3, you get a minus 1. And this is 3 to the power of 4. I'm sure from here you can move on with ease. Yes, the powers become equal. 5x minus 1 is equal to 4. Bring the 1 over, you get a 5. So what do we get? 5x is equal to 5. Hence, x is equal to 1. Got it? Bring your 1 over, minus becomes a plus. 4 plus 1 is a 5. 5x is 5, so x is 1. Are you getting better? Isn't indices getting easier? Let's move on. Alright? One very important thing I've always told my students: never panic. Remain cool as a cucumber. Look at carefully the sum and ask yourself, what is the link? Let's look at this. What is the link? Cousin number 81 is related to 3. Yes. Once you've got it, remember, do a prime factorization on 81. Break down 81 and you see that 81 is 3 to the power of 4. Alright? So it is 81 is 3 to the power of 4. And the outside power here is 2x minus 1. Now let's look at the right hand side. This is the left hand side is equal to the right hand side. Let's multiply power. You get 3 to the power of minus 3. Plus times minus is minus 3. Now if you open this up, alright, you get 8x minus 4. You get 8x minus 4. And if you look at both of them are 3's, the powers become equal. So let's say it again, what becomes equal? 8x minus 4 equal to minus 3. You got it? The powers become equal. And how do I get that? I multiplied them. Good. Now we solve for x. As I said, this is an equation. In an equation, you are expected to solve it. So minus 4, when you bring it over, it becomes a plus. So 8x is equal to minus 3 plus 4. Simple mathematics. Minus 3 plus 4 is the same as 4. Take away 3. You get a 1. 8x is 1. Hence, x is 1 upon 8. Got it? Do you see it? Look back and reflect. All that we need to do in indices is to break down a number to its prime factorization. Look for the link, and from there, connect the powers, the relevant numbers that you're asked to find. Let's look at the next sum. We have a 4. We have a 2 to the power minus 3. We have a 32. Aren't they all related? What is the link? Yes, you've got it. 4 is 2 squared. Great. So you write it down. 2 squared. When you have a bracket, it means you're multiplying with this number. And what is that number? 2 to the power of minus 3. And what is 32? 2, 4, 8, 16, 32. So 32 is 2 to the power of 5. And you've got x plus 5. Remember the laws of indices again. When you multiply, you add the powers up. 2 plus minus 3, you get a minus 1. Here, power. You've got 5x plus 25. Right? So these are both 2. And the only way they can be equal, the left-hand side and the right-hand side, is when the powers become equal. Otherwise, they're not equal. You see the equal? Yes. So these two powers must be equal. Minus 1 is equal to 5x plus 25. Bring the 25 over, plus becomes minus. And so your 5x is equal to minus 26. Hence, what is your x going to be? Alright, I'm going to write above. Minus 26 is 5x. So x is going to be divided by 5. That's your answer. Alright, minus 26 is 5x. So bring the 5 over. It is minus 26 divided by 5. Now, sometimes it can be a little untidy expressing an answer like that. It's good to put it in a mixed number. What would that be then? Yes, your x is equal to 5 wholes minus 5 wholes and 1/5. Alright? So that means, let me write here, x is equals to minus 5 wholes and 1/5. Alright? Okay, look at that. I'm sure by now you know it. 9 is linked to 3. And 27 is linked to 3. That's the common link. And now we've got to change it to 3's. So 9 is 3 squared. And the outside power is 3x minus 1. And 27 is 3 cubed. 3 times 3 times 3 is 27. And write it down. Outside power, x over 3. Multiply, open up. You get a 6x minus 2. Remember, you multiply the powers. And what you get here, you multiply, the 3 and 3 gets cancelled. You get 3 to the power of x. As I said, the powers will then be equal. So you've got 6x minus 2 is equal to x. Bring your x over. It's a plus. When you bring it over, you get a minus. So 6x minus x is 5x. Bring your 2 over, plus 2. Bring over is minus. So your x is 2/5. Now you're an expert in indices now. Have you got it? Are you following through? Let's look at a little bit more. If you can do this, it's beautiful. As I said, indices may look really challenging, may look very intimidating, but have no fear because you've got the laws with you. Apply them, make it simple, and you will see that you can sail through. One look at the sum may make you want to run away from it. If you have fear and if you are not familiar with the laws of indices. But I know you can do it. Yes, let's go on together. Square root means the power of half. Let's write that first. A to the power of 5. Square root A, and there is a 3 here, to the power of half. And this is AY. Got it? Yes, you're in line with me. The square root here, what does that mean? It means it is A to the power of 3 and it's powered half again. And that's the outside half. Have no fear. It's this half is for inside. Alright, A to the power of 5. This is A cubed. It's a square root of A cubed. So that half is only for A cubed. Write it well. Alright, it's A to the power of 5. 3 times half, power is 3 over 2. Ah, you got it there. And the outside power, half. Alright, is equal to right hand side. Now this square root is for the whole sum. Where else this square root is only for A cubed. So this A cubed, that's why we've got the half there. Multiplied with 3, we get 3 over 2. Now, what do we do next? Remember, an times an. You add up the powers. 5 plus 1.5. You get 6.5, do we? 5 plus 1.5 is 6.5. And what is 6.5? 13 over 2, right? And don't forget the half outside. You've got A to the power of Y. Power, right? multiply them up, what do you get? A to the power of 13 over 4. So you are there right now. Your y will be, yes, 13 to the power of 4, because they're both equal. Your y is 13 over 4, which is 3 wholes and 1/4, right? So please do write that. Try to make it into a mixed number. Now let's look at this. So you saw just before that what we did. Look at it. It wasn't very difficult, was it? Why? Because we did it step by step, breaking it down, making it easier, and then analyzing. At the end of it, we got the answer. So let's do it the same way. 5 to the power of 2 minus x. Now if you look at 6 to 5, alright, we know 6 to 5. 5, 25, 25 times 5 is 125. 125 times 5 is 625, right? 5 to the power of 4. So we said, alright, hey, you, you look at 625 is 5 to the power of 4, and you've got an x. Now what does it mean when you have 1 upon 5 to the power of 4x? If you remember this law, if I have a to the power of minus n is 1 over an, right? Remember 1 over an, alright, is a to the power of minus n. So 1 over 5 to the power of 4x is none other than minus 4x, right? The law, we connect them. And here we've got this, and hence the two powers become equal. 2 minus x is equal to minus 4x. Bring the x together, minus 4x moves over, plus 4x minus x is 3x. Bring the 2 here, you get a minus 2. So your x is going to be minus 2/3. You got it? Got it. Great. Alright, if you look at that, is that going to be a problem? Are they linked in similar ways? Yes. Alright, let's look at this again. It's 5x minus 2. What is 1 to 5? 5 to the power of 3, yes. And multiplied with minus x. And what you get here is 5x minus 2. When you multiply with a minus x, you get 5 to the power of minus 3x. Remember your laws. When you have 1 upon, when you surface the 5 up, it's the power becomes a minus. A minus of a minus 3x will give us a what? A 3x. Great. So 5 to the power of x minus 2 is 5 to the power of 3x. The two powers then becomes equal. X minus 2 is equal to 3x. Bring the x over. Yes, you get a 2x here. Minus 2 and 2x. And so what's your x gonna be? Divide it by 2 and you get a minus 1. Isn't it easy? Right? Remember, look for the link. And then look at, once the link is done, express it in such a way it's comfortable enough for you to see how the left hand side and the right hand side can be equated. And then you solve for x. Are you moving on? Great, let's move to more harder examples.